Oh, hello there. It's really good you could all join us today. Fantastic to have people attend and looking at our webinar on why it's important that organizations really need to look beyond detection in terms of defending themselves from attack. You'll see straight away, by the way, that this isn't just something Deep Secure thinks is important. It's actually a recommendation from analyst Gartner in their report Beyond Detection. Now that was published about 18 months ago, I suppose, and one of its key recommendations is that you need to consider moving beyond detection. They actually talk in terms of something called transformation, which we'll talk more about in today's session, as a means of defending from concerted and sophisticated cyber attack. So there's a link there on the screen right now. If you have access as a Gartner subscriber, you can actually follow through on that link and find out a bit more about Gartner's view of the situation. So we're going to look at how you can move beyond detection, and in doing so, how that can help an organization become effectively immune to the malware threat. A couple of points of housekeeping. First of all, if I may, you should have a control panel that enables you to ask questions and to chat with the presenters and organizers here today. So please, make use of those. And if we don't take the questions as we go along, we'll be sure to bundle them up and deal with them at the end of the session. Okay, so I'm John Stevenson, and with us today is Tim Freeston, Principal Solutions Architect at Deep Secure. In this section of the webinar, to start with, we're going to look at why it's really important to look at how you move beyond detection if you want to be able to share business information safely. And then I'm going to hand over right away to Tim for a great demonstration of why defenses need to move beyond detection if they're going to step up to the challenge. So Tim, what have you got lined up for us in the first section of demos?
So the first couple of demos are just showing defeating some of the sort of threats that you might see in content and how threat removal can actually defeat those. So we'll run through a couple of different types and show it in action.
Great stuff, fantastic, thank you. And then we'll sort of take a little bit more detail in about Deep Secure's approach to the problem, to Deep Secure's threat removal, how that technology helps an organization to adjust their defense posture away from just trying to detect bad stuff and look at how it stops malware without even trying to detect it. We'll take a look at some of the use cases for this technology, and then we're going to have, I think, another couple of demonstrations. Tim?
Yeah. So same sort of technology, but this time how you can defeat some of the more advanced or sophisticated forms of hiding information, whether that's malware or trying to leak information out. That's how threat removal can help in that case as well.
Great stuff, good. And of course, we'll wrap up then with some questions from yourselves, no doubt. And Tim and I will share some pointers to additional information and resources that you might like to follow through on. Okay, so first of all, just a very quick word about Deep Secure. So we're a UK company based in Malvern, and a good place to be, right in the middle of the UK's cybersecurity hub, with organisations such as the UK's GCHQ and National Cybersecurity Centre, or NCSC, nearby. And we've got customers in several verticals, particularly strong in defence and government, and with an increasing presence in law enforcement and critical national infrastructure. So, why is it important for an organisation to consider moving their cyber defence beyond detection? Well, it all comes down to a very 21st century problem, really, the problem of sharing information, something which is just growing exponentially all the time. And fundamentally, the problem is that when you want to share information, you have to do so by accepting the data that carries it. And that's a problem because that's where the malware is hidden in the data. So incoming business information wrapped in data, and that data can contain malware. But there's also a problem going the other way. Outgoing information, so stuff you want to send to people, is also wrapped in data, and there in that data can be concealed stuff that you don't want to share. And this particular problem is really important to deal with because the threats, the concealment in that data is getting ever more sophisticated with each passing day. I think it was IBM, for example, who estimated there were 4 new zero-day attacks per second per year. So for the year, 24/7, 4 per second. And the problem is, now in 2020, these attacks are focused specifically on particular organizations that, they're targeted. An attack probably only ever gets used once, so it's got a very short time to live. Next time it's used, it'll be changed again and modified to attack a new targeted organization. And that makes them pretty much impossible to detect. Here on the screen, you can see some attributed quotes really attesting to that. But if we just look at a few examples, think about something like a fileless malware. It doesn't touch the hard drive, so really you can't detect that. Or a polymorphic file, something like a simple image. The image contains a script. On the one hand, it's an innocent picture. It looks just like a JPEG file. It behaves like a JPEG file. But if you want to, you can just rename it and then execute the script inside. Another good example, something like steganography, which is seen a significant rise in the last year or two. Not just being used as an attack channel, but as a command and control channel. So the attacker sends in a picture. The defense can't see anything wrong with that, but with the right tools, the malware is extracted from that picture and run to open up a bidirectional channel so that valuable data can be exfiltrated, can be stolen out of the organization. And just to sort of highlight that set of risks and challenges and to give it some context. The one example that stands out is the contractor at General Electric. This individual emailed himself 500 messages to his personal web account with photographs of sunsets in them. When he was finally caught and questioned by the FBI, he admitted he was using steganography to conceal General Electric's intellectual property, so their turbine designs, inside those photos and leak it out. And the key point here is he was actually identified as a threat by the FBI by other activities and confessed to the use of this concealment when he was caught. Otherwise, no one would have known that that's what he was doing. So there's a problem with this weaponized content, and that problem is one that isn't being addressed and really can't be addressed by using the detection approach we've all become used to. Because this slide here really illustrates this very clearly. There's a whole raft of technologies that have tried to address the problem of the malware threat and the problem of the targeted and concerted cyber attack. The diagram shows the different waves of technologies, from antivirus and sandboxing through machine learning and artificial intelligence, but the problem is they're all based on detection, on detecting malware. They're all looking at the data carrying the information and trying to find something bad in there. Now, that's okay, but the problem is the bad guys just find a way around it, and a single success is all it takes. Just take an example like sandboxing for a while. For a while it worked, for sure. And then the bad guys realized how to evade it by simply, not executing the payload and waiting until the content was released from the sandbox. So now you need to find a new line of defense, and you move to something like machine learning or to artificial intelligence. But again, they're based on the detection paradigm. So what we must conclude is organizations need to move beyond detection because they can't keep up with the ever mutating threat. Now, that's why here at Deep Secure, we came up with threat removal, a different approach, one that works because it doesn't use detection, and as such, it isn't subject to failure. With threat removal, we do something entirely different. We just extract what we know is valid business information from the data stream. We discard the data and build a brand new file that's safe to handle. That's the key difference here, not using detection. So I'll tell you what, let's take a look at that now. I'm going to hand you over to Tim for our first round of demonstrations.
Great stuff, thanks, John. So yeah, the first demonstration is really showing threat removal that John just described, and how that works on some example files here. So hopefully you can see my screen, and I've got some sample files in this folder over here, and I've got two folders over here. So this first one is representing our source location, and if I drop a file into there, we've got some software that's just monitoring that folder, and it'll push the file across an appliance that's doing the threat removal. And that process will clean that content and deliver it to the second folder, which is down at the bottom, which is the destination folder. So the files should appear in the bottom folder when they've been cleaned. So the first demonstration we'll show is this PDF file, so sort of thing that people share all the time. And this is a PDF, a fairly complicated PDF, I guess. It's got images, it's got text. You can scroll down it and you can do things like select the text. So the sort of PDF that people will share all the time. But in this case, we've modified the PDF slightly and introduced some JavaScript in there. So if you can see here, I roll the mouse over a certain part of the document. We've actually highlighted it to make it easier to find, but that could easily be hidden. And it runs some JavaScript, which could potentially be malicious. In this case, it's fairly benign. So we've got that PDF file, and what we'll do is we'll just drag and drop it into the source folder, and what you'll see is that the software picks it up and throws it across the threat removal process, and you can see it's delivered it straight away. So very, very quick process to clean these files. There's no hanging around trying to detect whether there's anything bad in there. It's all very much, everything gets cleaned that goes through the process. And you can see here the size of the original was 1.5 megabytes. And the size of the delivered one is just under a megabyte. So it's been changed in size. So we know we've done something to it. And typically the file size will go down from threat removal, partly because we're removing anything that's not really necessary in the file structures, and just delivering the information that the user needs. It doesn't always go down, but quite often it will go down. So let's open up the clean version of that file now, and what we should see is that it looks exactly the same as the original. So as a user, you get all of your files, all of the information in the files. You still get to select the text, etc., and it's effectively the same representation of that information. The only difference is that now there's definitely no malware in there. So if we scroll over that part of the document again, you can see the script doesn't run. The script isn't there anymore, and the script's not there not because we found it and removed it. The key thing here is we weren't looking for it. All we were doing was looking for the information and taking the information into the new version of the PDF and leaving everything else behind. So, and when you're not looking for things, you don't miss things, and therefore this works for anything, and any new malware that might appear, it will also leave behind, meaning that it sort of defends against zero-day attacks. So the second document I wanted to show you was this one. So this is a mortgage application form, the sort of thing you might have to fill in and upload to a banking site, that sort of thing. And in this case, it's been modified to have some malware in it. In this case, it doesn't run anything bad, it just runs the calculator. So because we've modified it to do that, but potentially that could have been some more malicious malware. And in fact, this document is based on some quite famous malware called Emotet, which is causing havoc in lots of different locations, lots of different industries. And it's a pretty nasty piece of malware. And this document is based on that particular malware. And we can see that. So if we take this file and we upload it to a website called VirusTotal. So this runs a number of antivirus engines, so antivirus scanning engines against files. So if we choose that mortgage application file and we upload it, what we should see is here that 30 of the engines have detected that it is malicious, and it's this Emotet virus or a variant of Emotet. So yeah, it's a pretty nasty piece of work. We've modified it to make it safe, but it potentially is a particularly nasty file there. And it just requires somebody to open it, and as you saw, it ran the calculator in this case. So yeah, good that 30 of these engines found that it was Emotet, but actually 31 didn't spot that it was Emotet. So this is really showing you that detection just can't be trusted to always find the malware inside things. If you're trying to detect the malware, you won't always catch it. And there's various sorts of AV engines on here. There are some using AI, there are some using signature-based detection, and none of these, heuristics and all of those things, they're good to a point, but they won't ever fully protect you. And in here we can see that just by modifying that malware a little bit to run the calculator has meant that some of these engines now don't spot it. And that's pretty bad. If you're running one of the ones that don't spot it, then you're in trouble. So let's put that file through the same process, and again we can see it's taken from the source folder, goes through the process, and it's delivered to the destination folder. And again, let's open it up, and we should see that this time the calculator doesn't run. So it's now a safe version of that document. The document itself is still exactly as before, so the user doesn't lose any information, but they can be sure that they can safely open it, and that's the key thing, really. So if we do that same thing with VirusTotal and we upload the new version, the new file, this transformed one, we should see, if we just go to the destination folder and choose that file on VirusTotal, and let's confirm the upload. That's now going to go away and try and see if there's anything bad in the transformed file. And what we should see when it finishes, and that's another thing here that if you're using detection, it's not quick. It can take a while to analyze and see whether there's anything bad in there. It's now going through all of those engines trying to see if there's anything bad, and nothing found. So we've cleaned it, we've made it safe. There's no trace of anything that certainly the AV engines are picking up to say there's anything in there anymore. And we know because we just opened it that it's safe. So just a couple of quick examples there of how threat removal is both very fast and it's very efficient in that it treats everything as potentially malicious and just cleans it, and there's no worry about whether it was good or bad to start with. You just know that what you're delivered is clean. So I'll hand back to you, John, to carry on.
Great stuff. Thank you very much indeed, Tim. Excellent to see those test files going through the threat removal process. Okay, I want to just dig a little deeper now into what went on there and get a little bit more detail around threat removal and on what it offers. So a couple of key points here. So the first one is when we built threat removal, we didn't try and build it on top of an existing detection-based approach in any way. So it's built from the ground up to address the problem. It's architected as a multi-stage process. This multi-stage transformation process, and that's the way to think of it. Yeah, it's got three key elements. So if we start, if you consider, for example, the PDF, we start with extraction. So we look at the PDF and we extract all that is valid business information from it. So the text, the images, the pixels. And then we write them to a separate data structure, something simple. It's like a simplified version of XML. And we throw away the original carrying data. And that's the key point, because that's where the malware is. So we've just pulled out the business information and thrown the carrying data away. And then we go to a second stage where we verify the data structure is simple and understandable. And if we're happy, we pass it to a third stage where we build the new file, a completely new file. Has none of the data attributes of the original, only the business information. So by design here, with something inherently more secure than a single monolithic process. In fact, if you're really concerned about security, you can even deploy each of the three separate phases, three separate components on three separate physical pieces of hardware. And if you want to go a stage further and give yourself really the highest levels of assurance and guarantee that nothing bad can come in, then you can do that middle stage, the verification stage, using FPGAs and verifying in hardware logic, because that gives you an incredibly small attack surface for the information flow, because it's that middle stage that protects your build. What does all that mean? Well, it means that in essence that nothing malicious can get in, that nothing executable can get in. And this approach, the approach we use has actually been incorporated, in fact, into the UK's National Cybersecurity Centre's NCSC's pattern for securely importing data. The reason I say that is the person who wrote the pattern introduced deep secure and threat removal into various elements of UK government. So in short, this transformation process, this three-stage process is secure by design because it doesn't use detection. It treats everything as potentially carrying malware, so there's no trust. Everything's transformed. If it can't be transformed, it doesn't come in. And as you've seen, it's fast and always safe. There's no performance degradation, whether you're talking about browsing or email or file transfers. And a really great thing to just take away here is that what you're effectively getting is future-proofing, because you've not got detection-based defenses that are always playing catch up with the next new piece of malware, the next new version of Emotet. What you have is something that basically is future-proofing your defense. Okay, so to summarize this section, I mentioned that the approach is one that's recommended in essence by UK NCSC. You can see on the screen a schematic of that recommended approach. Note, threat removal uses the key controls of transformation, and it does that because complex things are difficult to validate. Complex data is difficult to validate. It uses protocol breaks, for example, to prevent attacks at all protocol levels, network, application, and content. It uses flow control to prevent an attacker using the import channel to exfiltrate something out. And it uses verification, something that's performed on simple data structures, because that's what gives you the assurance. So at each stage, really, of the recommended import pattern, we're employing best practice in terms of what we do. Okay, so there are a number of typical use cases for threat removal. You can see some examples here, so file transfers and secure email, web browsing, web services. What I'm going to do now is I'm going to ask, I'm going to ask Tim to take you through each of those use cases and just say a few words about them. So over to you, Tim.
Great, thank you, John. So the technology sort of applies or can be applied to multiple different use cases, really. So we'll just talk about the sort of common ones here of file transfer, email, web browsing, the sorts of things that people are having to do day to day, and also web services, so machine to machine type traffic, and how threat removal can apply to all of those different use cases. So let's look in a bit more detail at these. So if we take file transfer to start with, there are multiple places where people want to share files, whether that's building or receiving files from a customer or the citizen, if it's a government, where they might have portals. That could be an on-premise portal where you allow the customer or a citizen to upload files. That mortgage application document was an example of the sorts of files that you might need to upload. All sorts of different scenarios you can think of there, really applying for various things, or giving evidence for benefits claims, or whatever it is. You know, there could be images, it could be expenses, multiple ways that you might need to upload documents from untrusted sources to a portal. And if that's on premise, then you can plug in a threat removal appliance against that portal, and that will do the cleaning of the files before they then get processed. Similarly, if you're building a cloud-based, internet-facing cloud-based portal, then you can run the appliances in the cloud, but also there's a threat removal service, which is a subscription software as a service, which gives you the same functionality through APIs. So if you're building a portal and developing one, then you can very simply add to your code calls out to the API to clean the file as it's uploaded, and it integrates really easily and really nicely. Lots of people working from home, obviously more at the moment, and need to bring files into their organization, and certainly VPNs and the like to access your organization's network have been under a lot of strain. And so, you know, they're not always the best solution to get access to your network, and also possibly not the most secure either. So there are ways of bringing files in through a threat removal appliance that's in your organization's network to allow you to upload files safely into your organization's network, and to make sure they're safe once and clean once they're in there. And if you've got things like segregated networks, so many organizations have segregated networks where their high value assets are held and kept, and that network is kept separate from the normal day-to-day business network, and it's sort of kept separate there. So again, there may be a need to move files between that segregated network and your internet facing network. And here, again, you can use tools a bit like the one we showed in the demonstration, where you can automate moving files from one folder to another folder across a threat removal appliance, or potentially with more user based traffic, you can sort of drag and drop files into a web interface and bring them across into that segregated network. And again, as John said, you can use high assurance versions of the appliance, which give you really good assurance that actually the defense is sound and is doing what it should be doing, and can be sort of enforced by the hardware. And then one final file transfer use case is sort of the bulk migration of data. So you may have either a bulk lot of files from an untrusted source, whether that's sort of merging networks from other places or from other organizations, or whether it's a network that you know has been compromised but you don't know how badly, and you want to bring all of those files into a new network and make sure they're clean as you do that. So that's really about bulk migrating that data through a threat removal appliance to make sure everything that comes in is clean. So quite a few different file transfer use cases, and there are probably more as well. Email, everybody uses email, and if you've got an on-premise email server, typically that'll be protected by some sort of email gateway. That email gateway might be in the cloud, it could be on-premise, doesn't really matter. But you can put the threat removal between the email gateway and the email server, and it just sits in the SMTP flow, and all of the emails going in and out of the organization then get cleaned as they're processed. So you can be sure that all of the attachments and the email itself actually is free from malware. And again, if you're running things like segregated networks, you may be doing email between those two networks, and the sort of high assurance version of the threat removal can be used there to still give that high assurance protection to the segregated network, but allow email to flow two ways between the two systems. Web browsing, so you're web browsing through a web gateway that's giving you the sort of security, so things like URL categorization and reputation and that sort of thing. It's a fairly common use case for users in an enterprise network. Then you can plug in threat removal alongside that, and that gives you protection for all of the files and actually all of the images on the web pages, all the static content on the web pages that gets downloaded can be passed off to threat removal to clean it before it hits the browser. And actually because it's so quick and because it can run all of those things in parallel, actually the user experience is no different to not running threat removal. So the users see the web pages appear and get their downloaded content in real time, and there's no sort of discernible difference to not using it. So because it's a fast process, it's not waiting around trying to detect stuff. It means you can do threat removal and still have a good web browsing experience. For the more sort of high assurance customers where they've got segregated networks and they don't want any sort of browsing to the internet directly, there are isolated browsing solutions, and there's some that actually are protected by hardware as well. So Garrison is an example of hardware-based isolated web browsing, good for sensitive segregated networks. And in that case, you're browsing to the internet, but you're actually just looking at a remote view of a system that's browsing the internet. But at some point, you may need to bring some of the files that you're browsing or downloading back into your network and to your desktop. And if you do need to do that, that's where you can bring in threat removal, and those files can be pushed through the threat removal process and delivered safely to your desktop. And then web services, so this is the sort of machine-to-machine traffic. So as well as being able to transform and modify and clean things like documents and images, the same process can be used against structured data. So if you have something like a web portal that's internet facing and offers up various services, and that will typically talk to a back-end server, and that's where your sort of information is, your sensitive information that you need to protect. Then threat removal can sit between those two servers and monitor and clean the traffic. Typically that would be things like XML and JSON traffic, and it will clean that as it goes through and make sure that it's exactly as it should be to protect the back-end server from attack. Similarly with mobile device management, lots of different devices might be going in to talk to an MDM server that's running in your network. But of course, those devices are out in the internet and could be compromised. So there's an attack vector there that needs protecting. And again, threat removal can be used. So as those devices talk into the mobile device management solution, they go through the threat removal process, which makes sure that all of the information is exactly as it should be, and there's no attack going on there. If you're running things like a SOC and you need to import data into that SOC, syslog and that sort of information, then again, that can go through this similar appliance to protect your security operations network from attack in that sort of data. And also if you're just have the sort of sensors that are picking up information from untrusted locations, and again, bringing that into a sensitive network or a network that needs to be protected, then again, it can go through this threat removal process to make sure that all of that information is exactly as it should be and is not being used to attack your sensitive network. So there are quite a few different examples there of how threat removal can plug into various different use cases in multiple networks. Let's just jump back to a demonstration, and we'll go back to the previous setup, which was the two folders. So it's sort of using the file transfer use case really. And we'll just do a couple more examples of files being handled with threat removal. And this is really showing that there are sort of advanced ways of hiding information inside files and inside objects that you won't find by the normal data loss prevention type techniques and by visual inspection. So you can imagine a file here with some credit card numbers in. You'd hope that actually most DLP solutions would stop you sending that sort of information out, because that could be sensitive. It probably is sensitive information. Don't want to be sending hundreds of credit card details out. But what if I took this image? So this image is a picture of two cats. Looks fairly innocent, and the sort of thing we might be able to send out maybe to a personal address or maybe upload to Twitter or somewhere. But if we take a look inside that document, what we should see, if we just edit it with Notepad, what we should see is actually there are a whole bunch of credit card details in there as well. And although it's a valid image, it's a polymorphic file. So it's a valid image, and it's, in this case, some valid HTML. And it means that we can get that information out, but it still looks like a picture. And that can be potentially quite dangerous, obviously. So if we put that file through the threat removal process, again, delivered instantly to the other side, and we can open it up and it still looks like a picture of two cats. So the threat removal process deals with images in the same way as everything else. It takes it all apart, builds a brand new version of it, still look exactly the same, you have all the right information. But now let's look inside it. And what we'll see is that this time the credit card numbers have gone. So we've extracted the business information, the information about the JPEG, and we've left everything else behind, including the credit card details. And that could have been anything. That could have been some malware that you're trying to ingest, or it could have been more information that you're trying to hide and get out, a bit like the guy from General Electric sending pictures of sunsets and hiding designs and things inside. All very possible with this sort of technique. Now you could argue that actually you could see the credit card numbers in there, so something could spot those credit card details and stop it, and that's true. You know, it's possible that some techniques could get in and see that sort of information. So let's look at a slightly more complicated one, and this one is a steganography-based image. So here we can see a picture again, but actually inside this information there are also some credit card details. But if we have a look in there with Notepad, this time we'll see we can't actually see any of the information. There's no way you would spot that there are credit card details in there, whatever you were doing. So this has been encoded using some very simple available on the internet tools that allow you to add information into an image. And we can see that by just using this tool here that we've built that allows us to grab this image. And because we put the information in, we can get it out again. So if we decode it, you can see here it says success, and we can download the hidden information that was inside it. So if we just do that, save it as output.txt, we can see this is the information that was hiding inside that image. So, and you can see there are lots and lots and lots and lots and lots of credit card details, all hiding inside that image. Not going to spot it ever when that's being sent around. Very, very unlikely to spot that sort of thing. So if we send that same image across the threat removal process, again, you can see it's very quick. It's delivered it to the destination. We can have a look at the image. Looks exactly the same. So now let's have a look at that by trying to decode the information out of it again. So we'll go to the destination and we'll choose that image and we'll try and decode it now. And you can see here now we can't extract the information. So the threat removal process has modified the image and removed any of that extra information without knowing it's there. So it doesn't have to be an image that you don't have to know there's steganography in there. It just cleans it as it goes through. And so obviously any malware that might be in there or any information that people want to leak out is removed as part of this process. And that really just shows that the threat removal doesn't have to know about it. It just cleans it. Okay, so we'll just head back to the presentation and we'll let John wrap up. There's just one more slide, and this is detailing the file types that that threat removal can currently handle, and this list is growing all the time. But the types on the left, the native transformations, these are the sorts of files that we can handle using threat removal. So as you can see, there's most of the common sort of Office and imagery formats, things like zip files, the structured data at the bottom here that might be for web services, they're all supported. And of course, embedded files inside, so you might have a document with an image inside or a PowerPoint with a document inside, that sort of thing. All of that's handled. There's also some extra technology that we have, we call a sidecar, which allows us to handle additional file types. So if we have one of these additional file types, things like legacy Microsoft Office or Adobe Photoshop, those sort of things, we can translate those files into this intermediate format, and that's one that we can then natively transform and put that through this process to make it safe. And then we can transform, a lot of them we can transform back to the original, some of them can't be transformed back to the original. So they'd be transformed, for example, a CAD become a PDF. But it gives you some additional file formats that you can handle in addition to the native ones. And again, these lists are growing as we add more file types. So with that, I think I'll hand you back to John, who can just give you a quick summary.
Fantastic stuff, Tim. Thank you very much indeed. So, key point to take away there, think for a moment, pretty well every one of the examples of an exploit that Tim's shown us will evade an existing detection-based defense. It'll go through, yeah? And that's at the heart of the reason why we all need to look towards defenses that move beyond detection. Okay, I can obviously been a question or two while we've been talking, which is really good. I'm just going to zoom in on them now. So first question is from Ran. Ran, thank you very much indeed. Yes, Ran is asking about how do we handle encrypted content and macros? Tim, could you just say a quick word about that for us?
Yeah, of course. Yeah. So obviously this threat removal technology is all about getting in and extracting the information. So encrypted content causes a bit of a problem because you can't get in and get to that data. So the current way of handling that is by default is not allowing it in, because that's the safest thing to do. And if you can't send the encrypted data in, there's no threat. But there are ways of saying and choosing different policies, if you like, to say, well, for this particular channel on the appliance, I'm going to allow that sort of traffic in, and then you can start to determine who's allowed to use which channel based on what's surrounding the appliance. So we sort of try and make it so that you can take the risk, and we think that actually things like password protected content are required by certain people, but not all. So that sort of process works for that. For macros, same sort of thing really, that you can't make a macro safe. You can't be sure that it's definitely safe. And therefore the default position is to remove all macros. That's not removing things like formulae in Excel spreadsheets, so they get transformed, but actual Visual Basic macros and that sort of thing are removed by default. But again, you can start to set up channels that will allow those in and use those judiciously. So you use those for the ones that you want to take the risk with. Future versions will be smarter, I guess, in terms of how they're handling that sort of content. So we've got various ideas around how that will work, and look out for that next year.
Great stuff. Thank you, Tim. Hopefully, Ran, that answers your question. We also have a question here from, I hope I'm pronouncing this correctly, Oyvind. Oyvind says, how do you always know what is useful business information in the file? Are there cases where this is not clear cut?
Excellent question. Yeah, and yes, that's where really the knowledge of the file formats and the experience that we have in those file formats comes in, because you're right, it's possible that we could decide that a piece of information isn't relevant business information and therefore wouldn't be taken and transformed and would be left behind. So it comes down to a lot of experience and testing against file formats and customer feedback, I guess, because if we do leave a particular thing behind and somebody needs it, then they'll shout about it. They do shout about it, and we can fix it up. But really, by a long process of looking at what's in those file formats and making sure we understand down to the very last degree what they all are and what they're used for. That's how we determine it in the first place. The good thing about that way of doing it is that it's fail safe. So if we only take things that we can safely transform, we'll never take something malicious across. And so the default position is always it needs to fail safe. If that means that there's a particular element of a file format that we haven't taken because we can't make it safe or because we don't understand how it's used, then you've still got a safe version of the file. And then, as I say, if there are particular things that we've missed, then we can go back and add those afterwards, but we know that it's safe. So, and that's really how we developed the sort of Microsoft Office suite, was to start and we probably had sort of 85%, I guess, of the functionality, and then grew that functionality over time. So over time, that sort of went right up. So now that we deliver, a fully functional Office documents, I don't think you'd find anything in there that you don't get delivered now. But it was a process over time to make sure we got to that point, but it was always safe as we did it. I hope that answered the question. It was a bit rambly, but
No, I think that was great. Thank you very much. And obviously, looking at the question panel here, I don't think we have any more questions. No. Okay. So fine. Before we go, then, here's just a couple of pointers to further information. So, attached to your invite for the session today, there's a briefing paper on the UK NCSC guidance regarding secure import and export of data, and how we go about implementing it. You'll also see that I have attached a sort of briefing paper on the concealed threat and how to deal with it, really highlighting the need to move beyond detection. And together with that is a case study looking at how a government decided to implement the technology in order to render documents and images being submitted by the general public through governmental portals, which is quite an interesting read and worth a look. So, and one other thing, I've also included a PDF of today's slides, so you've got that as a matter of record. So thank you very much indeed for attending. On behalf of Tim and I and Deep Secure, I hope you enjoyed this session, and I will say goodbye. Thanks a lot. Bye-bye now.
Bye.